With innovation and advancement around the globe, the conventional power system needs to be upgraded with emerging technologies for reliability and efficiency. One such innovation is smart grid. To have a brief idea in what and how smart grid function, let's take a look at smart grid in Jeju Island, Korea. Jeju Island is a volcanic island dominated by Halsan with an area 1,846 km square and is the best known tourist destination with 5 million tourists visiting the island annually. Next topic is ownership and investment. When the world was just talking about smart grid in year 2009, Korea by then was already in first phase of implementing smart grid testbed under Korea Electric Power Corporation, which is an electric power generation, transmission and distribution company. The project was financed by government and private companies with total investment of 240 billion won, approximately equal to 208 million USD, of which USD 56 million was from public fund and rest from the private investment. The project started with following objectives. The main objective of the smart grid in Jeju Island was to make the Jeju Island carbon-free by year 2030, followed by the establishment of new market for two-way power threads with various resources in the demand side, facilitating negative generation and demand response. The development of smart grid ICT infrastructure for bidirectional information exchange based on power IT technology to facilitate electricity market trading and create new value-added services, and also to develop a smart system and smart applications to enable customers with demand response and automatic control responding to time-variant or real-time tariffs. Now, with the objective, we have come to the components of a smart grid in Jeju Island. There are 5 major components, namely smart transportation, smart place, smart renewable energy, and smart power grid, along with smart electricity market. As I have already listed out the components, now it is essential for us to learn about the goal of all the components that are listed above. First of all, smart transportation. The goal of this is to build a nationwide charging infrastructure for electrical vehicle. Number 2, smart place, to encourage consumers to save energy by using real-time information and producing smart home appliances. Then comes to smart renewable energy, to build a smart renewable energy power generating system by rolling out micro grids. Then a smart power grid. The goal of this component is to build a reliable and high-quality power supply system. Smart electricity services is to improve consumers' right to choose by satisfying their various needs. And with the goals of the components listed, now it is time for us to see the advancement in smart transportation that has been achieved in Jeju Island. With the vigorous innovation, electric vehicle has been developed and used in day-to-day life. Electric vehicle and charging point plays a vital role in a smart grid as it acts an energy storage system. To ease the transportation and give a user-friendly public transport, Jeju has established a electric vehicle for public transportation. The vehicle's compact 15-seater body enables it to navigate the narrow roads of this small island with ease and without producing carbon emission. The e-bus 7 can travel a minimum range of 200 kilometers on a single charge. The charging station established at various points and it takes only 2 hours to be fully charged. To encourage the public to use electric vehicle, Government of Korea provide subsidy for purchase of every electric vehicle. There are around 7,000 electric vehicles on Jeju Island, making up around 50% of total number of electric cars. Now let's discuss about smart place. A smart place means a smart home. With the solar rooftops in the most of the homes, the consumer becomes prosumer. When there is excess generation, power is fed back to the grid. The figure gives us an idea on how a smart home looks like. The smart homes have various sensors installed to maintain temperature, sense the motion, sense the intruders in doors and windows with the help of windows and door sensor, remote control. And the following picture depicts a prototype of a smart. The figure shows a concept of home energy management. The data from smart meters, water meter, sensor, which are recorded in minutes or seconds, are stored by energy management server and shared by a secure home area network and stored in a cloud server. This data can be viewed by a public or the residents or anyone who wishes to view the data in real time through this server. Now let's discuss about the third component, that is smart renewable system. The smart renewable system comprises of a solar farm, a wind power plant, and a biogas plant. First, let's discuss on solar farm. In recent years, Jeju has seen mass development of solar farms. It's already a major share of renewable energy sources. The total of 5.1 million square meter of farmland to be converted to solar power generating facilities by 2030, which would result in aggregate power output of around 340. Next renewable energy is wind energy. Currently, Jeju has a total of 6 wind power plants generating 272 megawatt of power. Initially, a 30 megawatt offshore wind power plant with 10 mil was built, which was capable of powering 7,000 homes. Next form of energy is biogas plant. To help local livestock producers preserve island's natural environment, Cargill awarded a US 500,000 grant to Jeju National University in 2011. The donation helped in construction of biogas plant designed to process manure from local swine producers in new ways. The state-of-art facility redirects waste into covered fermentation. The fourth component of smart grid in Jeju is smart power grid. The smart power grid has following components. A. Distributed generation and storage for clean and renewable energy supply. It comprises of PV and wind generation, fuel cell, and energy storage system. B. Power grid network and devices for enhancement of grid reliability and safety. It comprises of network management, advanced metering infrastructures, and electric vehicle charger. C. Operations center and energy management system for intelligent energy management, comprises of real-time balancing, big data analysis, and energy management system. Successful operation of a smart grid will require secure and interoperable ICT infrastructure and platforms to support new devices and services such as demand response, building energy management, and power retail. Demand response will enable utilities companies to curtail the consumption of energy by home and business users during time of peak demand by controlling the use of electricity and appliances at customer premises and rewarding them through price discounts and other incentives. KT's operation is a smart grid NOC, Network Operating Center, built on its open service platform. The platform interworks with variety of connected devices and the legacy grid network and provides third-party. All the generating stations are interconnected within the Jeju for stability and efficiency, connecting it to the main grid as necessary. Thus, this is being achieved through HVDC interconnection. HVDC interconnection of 100 km with 200 megawatt capacity is being constructed. HVDC interconnection is most efficient, cost-effective, and environment-friendly way to evacuate power over long distances. The benefits of smart grids are as follows: improvements in power quality, reliability, and cost-effectiveness of system operation from advanced metering infrastructure and related technology, reduction in greenhouse gas emission and stimulation of green energy use, added service such as demand-side management by optimizing power consumption pattern, cost saving through load shifting, and cheaper hours with economic incentive.